What is energy? Energy is the ability to do work. So our man throwing a baseball is using energy. Our balls knocking into each other is using energy. Our states of matter are using energy, and our little man pushing a square is using energy. What does this mean exactly? This means that energy is needed to apply a force to an object to make it move. Energy is also needed to make a change in the state of matter, so to turn a solid into a liquid into a gas, or a gas back into a liquid, or a liquid back into a solid. Kinetic energy is the energy of motion. So our girl playing tennis, she is using kinetic energy because she is in motion. The ball is using kinetic energy as her racket hits it. And then the racket is using kinetic energy as she swings. Potential energy is when an object is not in motion and has the potential to be. So it is storing up energy until it becomes mobile or in motion and then turns into kinetic energy. Thermal energy is the total kinetic energy due to the motion of the atoms in a substance. How do you measure thermal energy? With temperature. This is the measure of how hot or cold something is, specifically a measure of the average kinetic energy of the particles in an object. Temperature equals thermal energy, which equals the speed of the particles. You try it. Which of these thermometers shows a temperature that has the most thermal energy? Did you say this thermometer? If you did, you are correct. This thermometer shows the highest temperature, which means it has the most thermal energy. Which shows an object that has the least speed in the particles? Did you say this thermometer? Because if you did, you are correct. This thermometer shows the lowest temperature, which means it has the least amount of thermal energy, which means its particles are moving the slowest, because thermal energy is about the kinetic speed of the particles in matter. Thermal expansion is an increase in the size of a substance in response to an increase in the temperature of the substance. So matter expands with heat energy. The particles move faster and further apart. This picture is showing a bridge joint that allows a bridge to expand and contract as it gains and loses heat energy. Right now, the bridge is experiencing heat energy, which allows those almost like zipper teeth to move away from each other without destroying the bridge or without the bridge cracking and falling apart. As the bridge loses heat energy, those metal grooves will come back together and almost be completely closed because it has contracted when it loses heat energy because the molecules are moving slower and closer together. Energy can be transferred from one system or one object to another in several ways: mechanically, electrically, thermally, and with electromagnetic waves or electromagnetic energy. Let's first take a look at mechanical energy transfer. This roller coaster is an example of mechanical energy. Riding a bike or kicking a soccer ball or headbutting a soccer ball are also forms or examples of mechanical energy. Because mechanical energy is when objects push or pull on each other. So when you pull on your dog's leash because he won't move, or when you push and push on a door that says pull, you are exerting mechanical energy. Electrical energy transfer. The power lines you see when you drive down the street are all part of electrical energy. This simple circuit is also an example of electrical energy. You have the light bulb or the item that you want to power. You have a switch. You have a a power source like a battery, and you have a closed circuit. Those things are required in order for electrical energy to transfer from the battery to the light bulb. When an electrical source is plugged into an electrical device forming a complete circuit, you have electrical energy transfer. Some examples are turning on and off a lamp in your house, charging your phone or plugging it in and hoping that it charges, and plugging in a toaster and toasting your bread. You plug in the toaster into the outlet, which stores electrical energy, and that is transferred along the cord to the toaster so that it is able to toast your bread. Electromagnetic waves are another form of energy most commonly found from the sun. This is a special type of energy transfer because it can transfer through matter or empty space. This is the only type of energy that is able to transfer through empty space. It does not need matter to travel through. Other examples of electromagnetic energy, the radiation from the sun. So when you lay out in the summertime and you get burned, you are absorbing the energy from the sun into your body, which can cause you to turn pink or overheat. A space heater is another example of electromagnetic wave energy. Although it uses electric energy to plug into the wall, the fact that we feel the heat without touching the heater is an example of electromagnetic wave energy. The heat is moving through the air to us without us having to come into contact with it. You can't really see electromagnetic waves except for with infrared imaging. So here up in the top left corner, we have a picture of a heating duct, and when it is shown under infrared imaging, we can see the heat coming off of it, especially in certain areas. Finally, thermal energy transfer, which is the one we're going to focus on the most this unit. These particles and the sum of all the kinetic energy of the atoms in an object are thermal energy. So as these particles move and bounce off of each other within an object, their kinetic energy is transferring thermal energy. So we have a flame that's heating up the particles nearest to it, which then heat up the particles next to it, and that keeps going until they're all the same temperature. Like here, we have a flame heating up a pot, which is then traveling up the handle and into the hand. Heat transfers between objects of different temperatures, and it always travels from hot to cold. So the hotter object will transfer the heat energy or the thermal energy to an object that is colder. It never goes from cold to hot. The energy is always traveling from hot to cold. And it will do this until it reaches thermal equilibrium. What is heat? Heat is thermal energy. It's the flow of energy from one material to another. Which one of these has more thermal energy? A, the solid, B, the liquid, or C, the gas? If you said the gas, you are correct. It has the most thermal energy because those particles are moving the fastest. The solid has the least amount of thermal energy because they are the closest together and only allowed to vibrate instead of move around each other. Thermal energy transfer always transfers from the warmer objects to the cooler objects until thermal equilibrium is reached. So when this warmer object transfers enough heat to make this cooler object equal in temperature, they will continue to transfer until it happens. And again, thermal equilibrium is the point at which two objects that are touching reach the same temperature. So here we have an object that is 100 degrees Celsius Here we have an object that is 20 degrees Celsius. The 100 degrees Celsius is transferring heat energy to the 20 degrees Celsius until they reach a balance of both being 60 degrees Celsius. Energy is on the move. When warm and cool objects touch, energy is transferred from the warmer object to the cooler object. You give it a try. Touch the metal on your desk or chair and your paper with your other hand. So you should have one hand on the metal and one hand on the paper. Which one is colder? Neither. They are the same temperature. I know you don't believe it, but it's true. They are both the same temperature as the room. Why do they feel different then? It has to do with insulators and conductors, which we will talk more about in another video. Remember, thermal energy transfer reaches thermal equilibrium when two objects have the same temperature. And then no thermal energy will be transferred. Finally, here is a review of the types of energy that we have talked about in this video: mechanical, thermal, electromagnetic, and electrical. Can you fill in the blanks below the pictures? If you can't, you really need to rewatch this video. If you can, you're ready to move on.